Related rates, that's one of the most difficult ones to do here for most calculus classes. But let's see how we do here. Okay, problem one, the length. We already kind of did this before. The length, we set it up already. The length of a rectangle is increasing. The length of a rectangle is increasing by that much per second. The width is decreasing by that much. How fast is the perimeter of a rectangle changing at the instant that the length is 10 centimeters and the width is 8 centimeters? So how do you set up things here? Let's see. There's a lot going on here, no? Let's I don't know. This year I just thought of just setting it up like this, writing down what we want to find and what would be the relating rate before we kind of write down everything about what it says here. So what is it that we want to find out? What we want to find out? What do we want to find out? At the very end, what exactly do we want to find out? How fast is the perimeter of the rectangle changing? Once we know exactly what we want, then we want to know how fast is the perimeter of a rectangle changing. And so what is this? How fast is the perimeter? What would constitute that in mathematics or in calculus? It's a rate of change, no? How fast something is, the perimeter is changing would be what? What should I write down as mathematically what that represents? It's a rate. It's the rate of change of something with respect to something. The change of what? dp with respect to what? So we want to figure out what dp dt is. We want to find dp dt. So what would be a formula that relates, let's see, that relates a length, the length of a rectangle is increasing by that much and the width is decreasing by how much is the perimeter? Well, perimeter, what's the perimeter of a rectangle then? That's what's going to help you here. And then we take the derivative of that. So the relating formula is perimeter form. What's the formula for a perimeter of a rectangle? 2L plus 2W. So that should get us going right there, and that should get us going. And we want to know what dp dt is. And so let's get that relating formula and let's get going with it. Perimeter is 2L plus 2W. And we're going to take the derivative of this because it's what we're supposed to do. dt, everything with dt. Yeah? So it'll be what? dp dt equals what? 2L dl dt? Yeah, I'm just trying to check if you guys are paying attention. So, yeah, is that good? And then what else? dw dt? And so we want to find what dp dt is. And we would hope that we know what dl dt is and what dw dt is from the given information here. So what are we going to do? The length of a rectangle is dp dt at what time? dp dt will equal to 2 times what? The length of a rectangle. So it means like we don't even, the L and the actual W's don't even come into play here. It doesn't even come into play. It doesn't even. What's DLDT? Three, the length of a rectangle. This would be 3 centimeters. That's DLDT right here, no? The length, that's DLDT, and the width is decreasing. The width, DWDT. That's DWDT here. Okay, so DLDT would be 3 plus 2 times DWDT is what? -5. And so it's independent of it all. 6. So DPDT would be what? 6 minus 10. 6 minus 10. Is that -4? -4 what? Is it centimeters per second? Is that what we have? So it's independent of using. You don't have to even use the. It's constant. No matter where you at. See, all this change at the instant that is 10 and 8. It doesn't even matter if it's 10 or 8, no? Because it's constant, no? Yeah, at any time, it wouldn't tell you when and what, because it's constant, the change. Is that good? Let's go with number 2. Let's do number 2, and like I just said, maybe we just want to get you started where you're just like looking at a problem. You're like, I don't even know what to start with, what to do. So go ahead and write it down, and then like. The 2 main questions you could ask yourself are like, what are we trying to find here? And then the next one is to find what formula can relate everything or get you to finding what you're trying to find. So if we approach it the same way, what is this? It's the same problem almost. The length of a rectangle, the length is increasing by 3 centimeters. The width remains the same. The width remains the same. How fast is the area? Oh, this is not perimeter. How fast is the area of the rectangle changing at the instant that the length is 10 centimeters? We want to find what? How fast is the area of the rectangle changing? So what is this going to be? dA dt. So what would be the relating formula? A equals length times width, no? A equals length times width, and let's get that A times width. A equals L times W, yes. Then we take the dt of this, and we're gonna get what? dA dt. This is gonna be what? Product rule. Yes, yes. So it's gonna be what? The first times the derivative of the second is what? dw dt plus what? W times what? dl dt. And now we can just go look for things here. So at that, so dA dt is gonna equal 2. Now this is different because we do have L's and dW's and like that. So the length of a rectangle is increasing. The length. So what is the length of a rectangle is increasing by 3. So this is gonna be what? dL dt. Can we just plug it in here then? 3 what? cm. Let's just put numbers for right now. And then is that dL dt? The width remains constant at 5. How fast is the area of the rectangle changing at the instant that the length is 10? And what's dW dt? The width remains constant, so that's 0. Oh, so then this is gonna go away, no? So it's gonna be what? 15. Is centimeters? Is centimeters what? It's area, no? It's area. This thing is. Well, yeah. This has to be square, no? It's area. Can't be. It's area. What do you guys think? It's area. It has to be squared. This thing has to be squared. All right. There's something wrong here. I got to fix that. All right. Let's go. Let me give you some time to think about this and set it up. All right. I gotta fix that. That's wrong. That's well, area is. a ladder. Sometimes to add to this, sometimes for some people want to see it and you want to draw it too. Let's see what I have. I don't know what I have, but what is it that we want to find? Let's see. Let's read this. A ladder that is 10 feet long rests against the vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 foot per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? So what is it that we want to find out? We want to find out how fast the top of the ladder sliding down the wall. How fast is the top of the ladder sliding down the wall? What do we write down, or how do we figure that out like we did the other ones? See, the other one we were doing dp dt and we were doing dA dt. What do we do here? If you want to call this h, you want to call this h. If you want to call that h. Yes, yes. So it depends on what you want to call, because the ladder is here, and so it's going to make some triangle, no? Some right triangle. And so it seems like you're going to use some Pythagorean theorem maybe. So maybe you can do a squared plus b squared equals c squared, or you can say what? X and y and z. And I'm going to stick to x, y, z for what I'm doing. So then if I do say it's y, then this dy dt. Now, so maybe you could have worked it out with just saying that h, the height. So it depends on what do you call the variable, the vertical to be that variable and the horizontal to be the variable. But usually we want to use x and y. So the relating formula would be what? I just talked about everything. What would it be? Pythagorean theorem, but we're not going to use a squared plus b squared equals c squared. We want to use something more like x squared plus y squared equals z squared. But I do have a squared plus b squared equals c squared, but we're going to use x squared plus y squared equals z squared. So we're going to say that this is x, this is y, this is z, and then you can go ahead and write down x squared plus y squared equals z squared, and then do it like we were doing d dt like this. Yes? So it would be what? 2x, what is it? dx dt plus and now we can just, we could just put in numbers, knowing that we want to find what? We want to find out what? dy dt, no? You could go ahead and just plug in numbers, no? Yes, do you understand? We can just solve for that dy dt. You don't necessarily have to solve for dy dt and then plug in numbers. You can plug in numbers right now. So now we go to a ladder that is 10 feet long. What does this represent? A ladder 10 feet long. I think this is the ladder. Yes? That's z. So we can go here, no? 2 times rest against the vertical wall. If the bottom of the ladder slides away from the wall at a rate. So what does this represent? If the bottom of the ladder slides away, that's dx dt. Yes? We're okay, no? We're doing this. Dx dt is going to be 1, no? I don't know. I'm not putting dimensions here. Later, we'll figure it out at the end, I guess. And then what else do we got here? How fast is the top of the ladder sliding down the wall? When the bottom of the ladder, okay. What does this represent? This represents what? X? X, where's X? Here? X is 6. So we already put 2, we got X, we got dx/dt plus 2. We got a problem here. We got a problem. What problem do we have? What is Y? What is Y? We got a problem for what Y? And what is dz dt? What is dz dt? What is Z? What does Z represent? The ladder. Is the ladder getting bigger and smaller? So what is this? Does that make sense? We do need to figure out what Y is, no? How can we figure out what Y is? Pythagorean theorem is correct. Don't we already know what X is? Isn't X equals what? X equals 10? Oh, no, it's not. 6. What is 10? And then we can do Pythagorean theorem to figure that out. So A is X, so be 36 plus Y is B, so be B squared equals 100. Subtract 36, you get B squared equals 64. B equals what? 8. So Y is 8. So now we can figure out what dy dt is, because we got all the numbers for everything else. So this one goes away. This goes away because that's 0. This is what? This is 12. Move it over to the other side. Yeah, it's going to be negative 12. Negative 12 equals 16 dy dt. Then divide by 16 both sides. And so dy dt is what? Negative reduce, what's that? Divided by 4? That would be what? Negative 3 over 4. And that's going to be what the dimensions? Feet per second. This should be feet per second. No, it's just the length. No, it's not an area. All right, so I don't know. So you wanna, if this is a free response question on the AP exam, you wanna maybe summarize it and say, since I don't know, this is good. This is good, but this I got this I guess from somewhere. Since dy dt is less than 0, the distance from the top of the ladder to the ground is changing. What do I have? What the heck do I want with this? It's decreasing. From top of the ladder to the ground is decreasing. I guess that's what I want. Decreasing. I don't know where we have answered the question with this. At a rate of what? That's 3 over 4 feet per second. It wouldn't be no negative. It just, again, that's a double negative, that makes it positive. Because we already saying it's negative by saying decreasing. Let's go, one more. That's enough. The top of the ladder sliding down the wall at a rate of whatever. It's like saying it like so many times. All right, let's go. Number 4. a person stands 30 feet from point P and watches a balloon rise vertically from point P. So there's the look at that balloon rise up straight up. So there's you, there's a big balloon rising up. A person stands 30 feet from point P and watches the balloon rise vertically. The balloon is rising at a constant rate of 2 feet per second. What is the rate of change in radians per second of angle theta at the instant when the balloon is 40 feet above point P? What do we want to find out? Anybody, what do we want to find out? The rate of change of angle theta? Yes? So this is angle theta, no? It's the between the horizontal and where you see the balloon, no? So we want to find out the rate of change of angle theta. All right? So what is that? What are we going to do? What is this? What do I write? How do we put this into math? The rate of change of angle theta. The rate of change of the angle, because the angle's like it was zero, then the angle there was an angle between it because it was then. So what is it? What do we want to find? But anybody, what do we want to find out? Am I going to answer my own question? It's right there. It's telling you a rate of change of theta with respect to what? D what of change of what over this is always over T, almost always theta, the rate of change of the angle, no? D theta dt. So now the next question is the one that is, what's the relating, what formula do we use? Yeah. Yes. It's tangent. We could use tangent. It would be y over x. Let's do that. So yeah, like when you over here trying to do a Pythagorean theorem or something, there's no relation whatsoever with theta and with, because those are relationships with the sides of the triangle, not with the angles. So yes, let's go. Relating formula is going to be tangent theta. So let's go with tangent theta. And let's take the derivative of this. D dt. What's the derivative of tangent? Jeez. It's the derivative of tangent. What's the derivative of tangent? What's the derivative? Is it secant squared? Somebody look at their notes. What is it? Is it? I want to. Yeah. It is secant squared? Secant squared theta? D theta? Yes. That's where we're going to get that D theta from here. D theta dt, no? let me like get you to another point here, because otherwise, unless you want to do the quotient rule. But in this situation, don't we have something that's already a constant? One of these is a constant. X is a constant. And I'm already going to put that in because I don't want to be using the bottom times the top and the top to the all that. No, I don't want to use that because it's already a constant. And let me already plug in the constant. 30, no? So it'll be what? Y over 30. 1/30th of y, maybe? But hold on. Maybe I should have done it already here because that's not the derivative. Let me put it here. Yes. And so it'll be 1/30th of y. Yes. Just to make it a little easier, 1/30th y. And so they will be 1 over 30 dy dt. So what is it that we want to find out? We said we want to find out what d theta dt is, no? So we want to find out what this is right here. So we can go ahead and start plugging in numbers for things, no? Let's do that. Do we know dy dt? What is it? dy dt, that's like the balloon moving up at 2 feet per second. See, it goes back to trig, knowing trigs, secant. What is secant? Didn't we talk about what secant was? We can do this problem, or we can do this. What did we say was secant was? Secant theta is what? What is secant theta? So if secant squared theta would be 1 over cosine squared theta, no? Let me just put 1 over cosine theta, squared theta. And to get rid of this, to just put it over there, it'll be what? It'll be times both sides by cosine squared theta, no? Yes? I just want to get rid of it from this side already. And then that would cancel this, and I'll just have that dy dt that I need. But now, so this already, I'm going to go ahead and do what? 2 over 30 is 1/15? I don't know. Or leave it 2 over 30 right now, or whatever, no? This we already got. But we got to figure out what cosine theta is and square it. So can we figure out what cosine theta is? How can we figure out cosine theta? What? At the instant when the balloon is 40 feet above, isn't y 40? Well, we want cosine. What is the definition of cosine? Cosine theta is x over what? Z. So we need to figure out z, no? But isn't that a 30, 40, 50 triangle? A 3, 4, 5 triangle? Yes? You know it's a 3, 4, 5 triangle. So this is going to be 50. You can verify it if you're not, if you don't believe me, you can just go ahead and do all that. A squared plus b squared equals c squared, and you'll get that. So then we're going to get that cosine theta would be what? And then square it. Cosine theta is what? 30 over 50. So what is this? 2 over 30. I'm going to go ahead and leave it as 30 squared over 2500. I'm gonna cancel out the 30 and the 30, leaving that 30 alone on top. I don't know, I'm just doing this quickly. That'll be 60 over 2,500. And then cancel out the 0, 6 over 250. And whatever that number is. Was that, divide everything by what? By 2, it'll be 3 over 125? Yep. 3 over 125 what? So it's an angle in terms of what? Does it say in radians, no? So it'll be 3 over 125 what? What is it? What is it? It's radians per what? All right, let's go number 5. So like I just said last time or last class, we're gonna be doing triangles. Like that's, I guess, my focus in teaching this related rates, but it can be done with anything, balloons, with spheres, cones, or next 5, an isosceles right triangle with legs of length S has area that at the instant when S equals root 32, the area of the triangle is increasing at a rate of 12 square centimeters per second. At what rate is the length of the hypotenuse of the triangle increasing in centimeters per second at that instant? So we want to find what? The rate of change of the hypotenuse. So we're gonna we want to find out what? If it's triangle and I'm sticking to my dz dt, no, I think if that's what it is, I don't know what I'm doing in this one, but I mean usually you want to find a rate of change of the hypotenuse dz dt. So what would be the relating formula? Well, what rate is the length? Well, wasn't the formula given here? Isn't it 1/2 S squared? Is it? So I guess it's assuming that this thing is like getting big or small, whatever, or something. This isosceles triangle. So it's saying that that formula is going to be that right there, 1/2 S squared. What? That's why I was like, no. Is that the related? See, now we're getting into more complicated. Like, how would you know which one is relating? Why would it be that? What's an isosceles right triangle, anyways? What does that mean? What is an isosceles right triangle? Let's see. No, that's wrong. That's wrong. What's an isosceles right triangle? It's because both the sides are the same right triangle. So this better be the same as this. Whatever. This is supposed to be the same length as this. So we want to find out what we say, dz dt. We want to find the rate of change of the hypotenuse, dz dt. So if we do say it's area, the area is changing. See, nowhere, anywhere is it saying that the area is changing. See, I assumed that it was the area, and isosceles right. The area is increasing. So it's talking about an area increasing. Okay, I don't know. I'm going to go ahead and use that I'm saying. That also is a formula we need. Area is increasing. Area equals 1/2 S squared. This is if this is X and if we call this X and Y, but they're the same, we can call it S and S. And then this is, I'm going to go with Z, I guess, for right now. But they're saying that S times S. And all right, this is okay. So now we do the, what? The d dt. So we're going to get what? dA dt equals what? S ds dt. Okay, so now what? What is it saying? That we know that what? At what rate is the length? There's no connection here. That's the problem. That is the problem. Because what's the connection between this and this? What is the connection? That's why we gotta connect this. Because we're getting ds dt and we want dz dt. And what we're getting out of this is, ds dt, and we're getting da dt. So where is dz dt here? Nowhere. So we have to find some other relating formula. So that's how you're gonna, that's what I would say. Just do what you, and then you don't find it, and you're gonna have to find another way. And the other way is the Pythagorean theorem. So we're gonna say what? A squared plus b squared equals c squared. So it's gonna be s squared, but don't we already have it? S squared plus s squared equals z squared. Yes? So what is s squared plus s squared? 2s squared equals z squared. And then we do the d dt of this. What is it? 4s ds dt equals what? 2z dz dt. Oh, look at this. It made its appearance. Grand dz dt, that's the one we want. So how do we connect all this stuff? How do we connect this stuff? Let's solve for something and something, and now there it is. Yeah. So we know dA dt, no? What is dA dt? 12 equals what? S. So S is, at the instant when S is root 32. So we know ds dt, what that's going to be, no? So we can get ds dt here, no? ds dt. So ds dt is going to be 12 over that, no? Yes? dA dt is 12. The area of the triangle is increasing at 12. The area is 12. S at the time when S is root 32. So divide both sides by root 32, you get ds dt. So then we go over here, because we want to get ds dt and just plug in numbers. So we got what? 4, and we know S again, no? Don't we? Look. Let me solve it then. Right here, solve it. ds dt should be ds dt is equal to 12 over root 32. Okay, so we got ds dt. But they're going to cancel anyways over here. 4 times s, where s is root 32, times that ds dt is 12 over root, they're going to cancel out. Equals 2 times z. What's z? If we know s is what? If we know s is root 32 here, we can find z, no? This is going to be root 32. This is equal to root 32. So z squared, a squared plus b squared equals c squared. So z squared is going to equal to, this squared, which is 32, no? Plus this squared is 32. So it'll be 32 and 32 is 64 equals z squared. Z is what? So we go, z is 8, dz dt. So here this cancels with this. 4 times 12 is 48. 48 is equal to 16. dz dt. dz dt is what? 48 divided by 16. So it's going to be what? 3 what? Centimeters per second. So just the way I went through it, sometimes the relating rate is not obvious. Sometimes you just gotta just write down some relationship, go ahead and take the derivative, and you figure out that that wasn't a related. That's why you want to relate one with the other. So you're gonna have to go get another one, and finally it shows up. Then relate both of them. I don't know what that is. Whatever. But it's 3, no? One more. Let's see, one more. Oh goodness. Let's go. Last one, I think. Last one. What time is it? 9:37? 9:40? All right, write it down. Let's go. Let's finish this already. Let's see if we can finish this one. At noon, ship A is 150 kilometers west of ship B. Ship A is sailing east at 35 kilometers per hour, and ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? Let's draw something, no? Let's draw it. So A at noon, this is A, ship A. This is A is 150 kilometers west of B. So this 150, the distance 150. And then ship A is sailing east. So A is going that way. And B is going north. So how fast is the distance changing at 4 p.m.? So let's say at time equal to 0, this one is here, and then this one's here, and then at noon, so 4 hours later, this one's up here somewhere, and this one is over here somewhere. So now we're looking at this triangle here. All right. So it has to be some a squared plus b squared equals c squared. So we're gonna do what? I guess I'm doing x squared plus y squared equals z squared. d dt 2x dx dt plus 2y dy dt equals 2z dz dt. What is it that we want to find out? What is it asking about finding out what? How fast is the distance between the ships changing? dz dt. Yes? The distance between the ships. This is the ship. Wait. This is a ship. Now this one, how fast is this changing? No? Yes? Good? So we're trying to figure out this ZDT, no? Do we have everything we need? We got what? 2 times x. What is x? Extra credit if somebody tells me what the x is.
1.
Um, hold on, hold on. Las Nunes. Hold on. Say what?
I said it's X that bottom line.
Yes.
It'd be 10.
How?
So it starts off.
You use the rate? Are you using the rate?
So it's 150 kilometers away, but then it's moving towards Shippey at 35 kilometers per hour for 4 hours. 35 times 4 hours is 140. 150 minus 140.
Yeah? Yeah? Yeah, well, it makes sense. Yeah, yeah. It's a rate, no? So if we think about it like that, yes. You already said. It has 4 selling 35, 71, 40, 10, 10. The XDT, what's the XDT? Do we know the XDT? They're giving us. Hold on. Well, isn't it? We're going towards. It's positive to the right and negative left, no? Because they're getting closer towards each other. Oh, okay. Relative to each other.
Yeah.
Okay. What's Y? Why is it 100? It's getting. So how much it has moved? So north 25 times 4 is 100. And dy dt is what? Two times z, 2 times. Then what's z? Well, if you guys already said that at 4, exactly at 4 is what? You already said it, no? This is what at 4? You said this is 10 and this is what? Huh? Then I guess you can figure out what that z is, no? What's z? Was z a squared plus b squared equals z squared?
Yeah, 100.49.
100.49? Yeah? Now this thing is getting all weird. dZdt. Just let's solve for dZdt, and I hope we're getting something closer to what it is. It makes sense, I guess. Yeah, it makes sense. So 20 So go ahead and do this. Go ahead and get all this solved. $20 times negative 35. What is that and all that? Solve it.
Negative 700.
Where's my calculator? Negative 700, negative 700 plus 200 times 20 for 200 times 25. 5,000 equals 100.49 times 2. Seems like I'll just round to 201. It's a little. Yeah, probably they're gonna get mad if you do too much rounding on it. They won't give you all these points. 500 take away 700 is 43. 4,300 divided by 201. 4,300. 21. I don't think is that the answer. Let's see. The problem would be like how this number, how for them, like how exact, how exact that number is. You know what? It's enough. You can think about this one, but that's enough.